I want to spend a little bit of time talking about our plan. Now that our schedule got a little bit disheveled from missing class last week, I still have not posted the virtual portion of the CAD for additive manufacturing from the class we missed on Wednesday when Ian was actually hitting. I'll probably get that posted hopefully sometime this week. I'll have a little bit of extra time because of BMES coming through. But what we're going to do is we had a few weeks here for review. We're going to take one of these 2 prep weeks off. And that's how we'll get our time that we lost from the hurricane back. And I'll post some additional virtual lessons with some CSWP practice problems to make up for that. And you can do those whenever you want. So that's my plan. Minimal impact on us in this class from that change, I feel. I don't even have dates on most of these classes yet, so that was convenient. Yeah, Marza. Yeah. 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 So if you go to, this is the lesson page for this week, what I'm calling week 8. And if you come to the bottom here, the link that I sent you in email is down here. You can register for this conference. It's free. Click on Save My Spot. And then you can click on Register Now and it'll let you register for this conference. And there are, I don't know, 20 something sessions throughout the day on Tuesday, October 18th. If you attend 3 of these sessions and just write a short 1-paragraph summary of the session you attended, and then you can submit that to what I'm calling the week 7 conference submission, then you can get 20 points of credit for that, like you would have gotten if we had class last week, right? So since we didn't have class last week, and since this class is being graded on a point system, I wanted to give you guys all an opportunity to get the 20 points you would have gotten from that class. And so I put that up on there. And it's optional. You don't want to do that, you don't have to. If you're going to BMES, you can also, instead of doing the online conference one, you can do 3 sessions from the BMES conference that you find have some relevance towards computer-aided design or manufacturing or product development of some kind, and then post that. And it could be just, here's a post. I saw a poster that talked about, 3D bioprinting, or I went to a session that was on manufacturing for medical devices or whatever, right? I'm not gonna be too picky about what that actually is. Just a nice way for you guys to get some credit for doing extra things outside of class. I actually did sign up myself for this conference. I'm going to try and send as many sessions as I can. A lot of the sessions are in parallel. So like there's a 12 o'clock set of sessions, a 1 o'clock set, and then a 2 o'clock set. And then, so obviously you're not gonna be able to attend all of those, but you can pick and choose the ones you want to do. Excuse me. Questions on either of those? Did anyone bring with them something that they want to engrave for the lesson today? No, no one brought anything they want to engrave. All right, so we'll start with just a, we'll make a generic box and we'll put something that we want to engrave onto that box. And then we'll go through the process of adding a machine to the CAM utility, which is the computer aided manufacturing utility in Solidworks, and then generating a tool path from the geometry with that machine. It's a pretty involved process of going through and getting from the 3-dimensional part to an actual machine path. And then that's only kind of half of the steps. The other half is actually getting the material, putting it in the machine correctly, putting the position of the machine set up relative to the material. So the 0, 0, 0 position that the machine says it is, and the 0, 0 position in your code are the same thing. And that's a lot of times that's where all the error comes in, is kind of any offset you have between where I said the part is and where the part actually is when you fixture it in the machine. So, sound good? All right, open up SolidWorks, make a new part. And I'm going to go on the front plane. I'm going to sketch. I'm going to draw just a regular rectangular box. If you want to model some other geometry, because you think, okay, maybe I'll do this for like a phone case or for a widget, a keychain, or whatever, feel free to use a slightly different geometry on this. The geometry that we're using for the work that we're then going to be cutting out is not really that important, just to be clear. I'm just using a box because that's the easiest thing for me to draw. So I'm going to use a center point rectangle. I'm going to make this 20 millimeters tall and 40 millimeters wide. That's 20 by 40. Pretty good, right? So that's about an inch tall and about a little less than an inch tall and a little bit less than 2 inches wide. So that might be like a keychain or something, right? Good kind of size, something like that. I'm going to accept that. Go into features, I'm going to extrude this. And I'm just going to make it 10 millimeters tall. On this case, normally I would use the mid-plane extrude. In this one, I kind of like having the origin of the part being at the bottom of the part. It's not going to really matter for what I'm doing going forward. But if I want to know what the depth of the cut is, that's an easier thing for me to look at if I have a plane that is on one side. So my general advice when you're making parts is mid-plane extrude. There are exceptions to that. So this comes going to do a regular blind extrude. So I've got like a little widget right there. I'm going to call that like a keychain. And then I'm going to add some features that I want to cut into this part. If I do actually want this to be a keychain, I might want to say, okay, well, I'm cutting this out from a block of material. And maybe I want to have a hole that goes to a corner of it. So I'm going to go to the front plane. I'm going to sketch. I'm going to put a hole on the top right corner. I'll dimension that hole. I do want to be kind of careful about how big I make these features. I can't make any features smaller than whatever the smallest bit that I want to cut with is. So if I'm going to use a 2 millimeter, milling bit, I can't make a 1 millimeter hole. So think about what size bits are you going to have available. Typically, like for the machine that we have here, we have bits that are actually in US customer units. I think the smallest one we have is a 1/16, but we can convert, right? So if I do 1/16 of an inch, that's 1.59 millimeters. I can make anything that's bigger than 1.59 millimeters. Maybe I want a 3 millimeter diameter hole, right? And then I can specify where this is relative to my edge. Maybe I'll make it 3 millimeters from the top and 3 millimeters from the side. And if I had an advanced manufacturing machine, so if I had a multi-axis machine that had a spindle that allowed for tool changes, it might actually have a 3 millimeter bit, and it could just cut that hole in one operation. We don't have that much advanced capacity for us, so we're going to try and keep our things fairly simple. Do features, extrude cut. I'm going to have that go through all. I'm going to make sure it's going in the direction of my part. Pretty happy with that. I'm going to go back to my front plane here. Actually, I'm going to go on the top of my part. So not the front plane, but rather the face of the part. I'm going to sketch on that. And I'm going to put some lettering on here. I'm going to make this lettering kind of as big and bold as I can get it. So I don't know. Something like that. I'm not going to use the document font. I'm going to go into font here, and I'm going to make this. This thing is 10 millimeters tall, so I'm going to try and make this, let's say 8 millimeters high. And I'll move it down. That's a little bit too short. So what I'll do is I'm going to go to my my first extrude here. Double click on that. I'm going to make this a little bit longer. So let's say 60. And then I'll rebuild. And then I'm going to edit my sketch. And I'll position this somewhere close to where it's in the middle of the part. Something like that. And I'll note here, I don't know how big this circle is, but I'll measure it after I cut it. So I'm going to do an extrude cut. And I'm going to cut this just 1 millimeter into the surface of my part. Yeah, Marza. Good question. So in my sketch, when you're using the letter tool, the note tool, at the bottom here, there's an option to use document font. If you uncheck that and then go into font, you can specify the height of the letters. In this case, these are 8 millimeters tall. If I make them 10 millimeters tall, I guess I made this 20, but now they're too long. I could also squish them closer together. Maybe 9 works good. Again, you can make this say whatever you want. You can make the font be whatever you want. But keep in mind that if we're going to use a 1/16 bit to cut this out, anything that's smaller than 1/16 isn't going to cut. And so one of the things I'm going to check on this is, okay, if I accept that, what is the size of this hole now from that font? So I'm going to evaluate, measure. This has an arc length of 1.5 millimeters. That's not super useful for me. Perimeter of 6.7 millimeters. So it should be pi r. It's getting pretty close, right? It's probably close, but maybe I want to make that a little bit bigger. And I don't have to worry too much about this right off the bat. I'm going to be able to see what my toolpath is when I go in and try and run this thing out, right? So if it turns out that with the tools that I have available to me, it can't cut this geometry, it'll tell me before I finish all of the operations. And so I can go back in, modify the geometry to make it thicker or whatever, right? And then edit it going forward. Sound good? Also, you guys don't need to make yours say Dr. Laura. You can make it say, Pedro or Owen or whatever, right? Use your creativity. It also doesn't need to be a square. It can be whatever you want. All right. But everyone have something with at least a feature or two on it? Owen, you good? Okay. So now I've got a part. I'm going to save it somewhere on my computer. Desktop's fine. I'm just going to call it keychain. I want to use this part to manufacture my piece, right? And to do that, I'm going to go to SolidWorks CAM. And you'll notice I have all these options up here at the top. To make this work, what I'm really going to do is I'm going to start on the very left where it says define machine. I'm going to work my way across from left to right. I also want to note that the SolidWorks CAM package actually is an additional add-on that we don't have access to as part of our kit here at FGCU. So we have like the CAM Lite version. And so that will not allow us to do 3D surfacing operations, even though it looks like it does. So it's kind of there, but we're going to be software limited from putting that in, or license limited from putting that in. So we're only going to be able to use Access 2.5 milling operations, which won't allow us to do complex surfaces using this machine. This is just a note I want you guys to kind of know. At this point, probably important for you guys to download and follow along with some of the options in this worksheet. So if you go to our lesson page for today, download both the lesson 7 SolidWorks cam.docx file, as well as the Carbide 3D GRBL control.zip. This GRBL, this is the assembler for the Carbide engraver that we have in the lab. So SolidWorks doesn't know what machine code our specific machine speaks. So it needs to have some piece of software that says, okay, I want to move from this position to this position to this position to this position. If you remember our kind of breakdown of machine code in class like 3 weeks ago or whatever that was, right? We looked at the G code where it was G1 and then XYZ position, G2, XYZ position, G3, XYZ position. Y'all remember that? So SolidWorks will generate those positions, but it needs an additional piece of software that says, this is how I translate that desired movement into the code that this specific machine will be able to interpret. So that's what this GRBL piece is going to do for us. So once you've got those downloaded, come into this file and copy this C/program data SolidWorks SolidWorks post mil. Open up in a file explorer window. So if I just open up a new file explorer window, let's do a civil biomechanics. That's fine. Or not. Oh, it's because I have this open. Maybe try closing it. I wanted to do this from scratch. Wanted to try to do it from scratch. I'll just go to a different folder. Oh no, there it goes. If I copy this directory, and then I come into the directory in this file explorer window and I paste it in, get rid of the A. So it's just C and hit enter. It takes me to that folder. This folder is a hidden folder inside of the C drive. So if I go to C, you notice I don't see program data. If I had the ability to, well, here's hidden items. If I turn hidden items on, then I can see the program data. That's where it is, right? So we need to put the files from the zip folder into that directory. So I'm going to go to that directory. And then I'm going to open up the zip that I downloaded. And I think I can just copy and paste these straight in. But let me look at my notes right here. Copy and paste rather than drag and drop to avoid images. I don't know how that works. So I'm going to right click copy, come over to here, right click paste. And I got those files now in this folder. And you can see there's already some there, right? Siemens, Mach 3, Mazaka, right? Where they're just adding this set of files to the listing that SolidWorks will have access to. Questions on that? The next thing we need to do is, since the machine that we want to use is not actually inside the default machines in SolidWorks, we need to define that machine inside our database. So in SolidWorks, up here in the very right-hand corner, you see this technology database button. That's going to allow us to look at the list of all the machines that are available to us and define new ones based off what we need. So click on that and then wait a few minutes for it to actually finish loading in. The technology database on the top right. And it should load after, a little bit of time. Message window. There we go. Loading, loading, loading. Now we've got this listing. And what we want to do is we want to make a new milling machine in our database that is the Nomad 883. So I'm going to start with a default metric mill. Actually, I'm going to switch to inches just because I know the Nomad runs in inches. So switch it to inches. I think we probably could define it in metric, but I think we wanted to do it in inches. So inches, I'm going to click on the metric mill. Wait for it to load that. And then I'm going to do copy. And now that I've copied it, it will let me change this part. So it doesn't want to let me, the default ones, it doesn't really want to let you edit. Once you've made a copy one, then you can start changing some of the parameters. And so I'm going to go through the parameters in here and try and make them match what I have in the worksheet. So I can make this the default machine. I can give the name Nomad 883. It's a milling machine in inches. I have a metric there, I guess. I'm like ultra light duty. The processor I want to use, the post processor, is the one I just added, the Carbide 3D router.ctrl. So we should be able to see this in the mill folder. So mill carbide 3D router GRL. Again, that only shows up because we added that to our database in the prior step, unpacking those zip folders. So does everybody see that in their options? Seeing some heads nodding. Oh, and I'm assuming you're not shaking your head, so it's probably okay.
Yeah.
Good. Again, I want this to be light duty. And then you can say the different options here. Do you want to have subroutines? Do you want to have outputs? We don't need to mess with any of those things. The specifications, this is fairly important because the power capacity of the machine is important in terms of optimizing the tool passes that it'll do. So I'm going to make this horsepower 0.1. The motor on the engraver actually is a little bit more powerful than that, but it's better to underpower in the simulation so that way you're not running up against the physical limits of the machine. So that's a good kind of approximation. Average indexing time, we can leave that the same. We're actually not going to move tools out. The max feed rate and the mid feed rate here, this one's in millimeters per minute, this is in inches per minute. So I'm going to cut this down a little bit. Let's say 100 inches per minute. And then the rapid feed rate, we'll say that as 200 inches per minute. And then I'm going to leave the feed acceleration rates as the defaults. It's all electrically controlled, so the accelerations there should be fine. And then I'm going to save this. And once it's finished shaving, I can actually close this, and then we'll actually set this new machine that we have in Nomad 338 as the machine for the part that we're doing. All this stuff gets saved under the user preferences. So once you've added a machine to your workstation, it will be there regardless of what part you're working on. The next step that we do is assigning the part or the machine to the part will save with the part as well. So when you move the part around, it'll know which machine has been assigned to that manufacturing operation. So if you're working in an environment that has kind of integrated SolidWorks throughout the production process, you can send a part that has machining operations on it to someone in your manufacturing, and they can just hit print, right? Or you can send them the files and then they can print from the files. But most of the time they want to see what the actual pipeline of the manufacturing is first before they print it so they can set it up properly. So that can be helpful. All right, so let's close this. I can close the messenger too. And then the next thing I want to do is I want to define the machine. So you can see here, we want to define machine. I think I'm gonna wait for a second because I don't want to get overzealous. Oh, it's because I'm in millimeters. I'm gonna hit cancel. I'm gonna change over to inches and then click on define machine. I should have just stayed in metric. There we go. So now I'm in inches and I define my Nomad 338 as a imperial system. And so that's where it shows up. I can hit select, and now that's the machine inside my configuration. You may also note that we have an extra window here at the bottom now, and we're in the SolidWorks CAM feature tree. We're going to move to the operation tree and the tool tree as well here in the future. But these are actually duplicates of the options up here at the top. So if you want, you can actually toggle between those, and you can see where all those different things are as part of your options in SolidWorks. So are you in inches per second? Yeah, change to inches, and then in define machine, you should get the option to have the Nomad 883. It's because we created that as a inch unit system machine. If you want to have it as an inch unit system machine and a millimeter unit system machine, you can do that. Just got to define it twice. And again, so I selected that one, then we should be good to go. The next thing we want to do is we want to find the tool crib for our machine. And we're actually going to use a little bit more simplified version than I have on here. This is all of the tools that you want to have access to when you're performing a manufacturing process. An advanced milling machine will have an automatic crib which will allow it to pick up and put down tools based off the operation it's trying to perform. The one that we have, the engraver, does not have it. You have to manually change the tool every time you want to do a different operation with a different tool. And Solidworks will allow you to include both the manual or the automatic tool changes, but you got to make sure that all the tools you list in the crib are ones that you have access to, or the machine has access to, or when you go to print, or really when you go to cut the material, it's not going to work, right? So we want to set up the tool crib. I don't have the button to push on here, but if we go from the machine, so there's an option here for tool crib. Let's go to the next tab over. There we go. It's loading in a default inch tool crib. What we want to do is we want to define a new tool crib. So what I'm going to do is I'm going to copy this one. So I'm going to do save tool crib. I'm just going to call it as mini tool crib. And you can call it whatever you want. Hit save. Again, I'm doing that because I don't want to edit the existing default ones. And then I'm going to go through and I'm basically just going to delete all but one of these. Remove tool. And then what I'm going to do is I'm going to edit one of these tools so you guys can see what the options look like on these. So I'm going to edit this tool. I hit remove tool. So there's this option here. There's add tool, edit tool, remove tool. I clicked on, I used shift to select all of them. And then I click on remove tool. But I click on this one up here and I'm just going to do edit tool. And so you see, this is the current tool I have selected. You notice it's a flat end mill, right? I also have options for a ball nose, which you can see it has a ball end, or a hog nose, which is like a corner chipped off the end. And I'm gonna use a flat. I'm gonna make the cut diameter 1/16 of an inch. Oh, I didn't actually want to exit that. I just wanted to exit put in the value. I'm gonna make the flute length here 1/2 inch. And the overall length, maybe 0.75 inches, pretty short. Number of flutes is 2 is fine. And again, you can look up all the properties of each of the tools, each of the bits that you have for your machine, right? So you can change these to whatever you want based off of whatever milling bits that you have. And if you have more milling bits that you want to use, that's going to allow you to make either more intricate cuts if you have smaller bits, or faster cuts if you have bigger bits, generally, right? So usually you use a certain number based off of how much you're trying to cut. Non-cutting portion, do you want it straight? Do you want it to have a different length? Are you a right-hand cut, left-hand cut? You know, and then there's different parameters here you don't have to worry about. Cutting parameters, again, you can associate with the stock material. You can also set the speed. Usually you want to use it based off the material that you're using for your stock. So I'm gonna click on OK. That's something I didn't really talk about, but the machine will specify cutting speeds based off of the tool type as well as the material type. So it is figuring out what kind of feed rate is appropriate based off of the horsepower of your machine, the strength and elasticity of your base material, your workpiece, as well as the hardness and some of the properties in terms of the diameter and things like that of the tool. I'm just going to call this the mini 1/16 mill. And I'll click on OK. And you can see here that it's got all those things updated. And for the sake of time, I'm not going to bother adding any additional ones. I'm just going to use just that one. Post processor, it should already be set to the Carbide 3D GRBL. We set that up when we set up the machine. So you can look at that. It's fine as long as it says that. The processing, do you want to do post processor? Where do you want to do offsets from? You can get all those from the post processor. You don't have to worry about it. And then most of these other things you can just kind of ignore. And we don't have a rotary axis or a tilt axis because it's going to be a 3-axis mill. But again, if you had more advanced tools, you could set that up there. Any other questions so far? All right, I'm clicking on OK. And the next thing we need to do is we probably need to set up our stock as well as our extracting some of the features. So in this case, we want to specify the stock manager. So if you double click on where it says stock manager, you can say, how do you want to define the material as well as the boundaries of your stock? In this case, I'm going to change this from aluminum. This is 6061 aluminum. I'm going to look for like nylon or some kind of plastic, polyurethane. Yeah, it's just polyurethane. Right. And then you can say the bounding box, basically how big is your stock? And right now it's made the stock as big as the perimeter of my part. If I'm starting with a bigger part, I can make this bigger or smaller relative to my part, or I can also load in specific sizes. So I can just say, I have a material that is this big, and then put my part into that, and it'll make cutting out the edges of the material part of the machining operation. In this case, what I'm really concerned about is not so much cutting out the perimeter of my part, but engraving in the Dr. Lura portion on the face of it. So I'm just going to leave that like it is. And then I'm going to set the coordinate system based off the corner of my part when I set that up. That should be good for now. You can go down to the options here. Number of parts, stock size, gives you the actual size of the stock. You're going to do that in inches or millimeters, so I converted it for me by default. And I'll go ahead and accept that. Now I have my stock defined. My coordinate system is not defined yet. That's going to be the next step for me. I'm going to double click on coordinate system. And you actually get to pick where you define your coordinate system. You want to pick a feature or a location that you can identify on the physical part. I typically use the lower left-hand corner on the face of the portion. So I would pick like just right here, the corner right here. So I'm going to user defined. I'm going to use part vertex. Click on this vertex right here. And I have my X, Y, and Z based off of that right there. So I'm using the bottom left-hand corner of the bounding box of my stock. And the X, Y, and Z axes are important. If you want to reorient them, you can. Z is, if you imagine a typical vertical mill, that is going to be the spindle height or the table height adjustment. And that's where you're going to get, like you were doing a drilling operation, the drilling operation would be in the Z direction, right? Where if you're doing face milling or end milling, you're going to come off in the X and the Y. And we'll see that here in a little bit. You can use any corner you want. You need to make sure that the corner that you pick on this system, and then the corner that you pick when you set your 0 in the machine, like in the physical machine later on, are the same. So you want to pick one that you can get to with some amount of ease. And so I typically use the lower left because usually that's pretty easy to find and get to. And consistency, I guess consistency is the only thing that matters. If you can do it consistently, you're good. If not, then pick something else. So there I've got that set up. Next thing we do is want to extract our geometry. I'm just going through to make sure I don't miss anything. So there's the extracting machinable features, right? And this is going to allow us to generate the machining operations that are needed to make the geometry of our part. So click on extract machinable features and then wait. And now we have irregular pockets. See all of them there? And we have 7. So there's 1, 2, 3, 4, 5, 6, 7 irregular pockets and 1 hole. Everybody see that? That? Well, I mean, if you have 5, do you have fewer letters? Yeah. So again, I have 7 because I have 6 letters and the dot, right? So those are 6 pockets, and then I have 1 hole. So I have 7 pockets and a hole, right? Those are the features that it wants to cut. Those features are purely based off the geometry of the part. They are not actually operations yet, because the operations have to account for the actual process of removing the material. So the next thing we're going to do is click the next button on the list. But you do want to make sure that the features that it identified are what you actually want it to cut, because that's what it's going to be using to make the actual operations. So geometry makes features, and then the features make the operations, and the operations make the individual steps for the motors to move through. And that's the process we're going to go through. So we have all these ones. Next thing we do is we're going to generate the operational plan. Also note that these are blue because they are undefined or underdefined. They don't have a plan yet. So I have a feature without a process to generate that feature. So the next step is generate operational plan. It's going to go through and say, okay, I have these tools and I have these features, and I have these materials. Therefore, I need to make these cuts at these depths and these rates. And it's going to do that for each of these kind of one at a time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There is some deal of kind of optimization that can be done here to make the machine take less time by like not doing tool changes as frequently or doing certain operations in specific orders. We're not going to get into all that. You could spend years as a machinist learning what the best practices are there. We're going to be more concerned with just being aware of the fact that we have to do a lot of these operations sequentially. There are some sequences that are preferential to others, and you can control that in the software if you want to. Hopefully this won't take too much longer to generate my plans. If you guys had fewer features, it may generate a little bit faster for you than it's doing on my end. But we'll wait a few seconds and see if it goes through. My attempt at being patient right here. Any questions while we're waiting for it to generate our plans? All right. Well, for the sake of time, let's preview what the next steps are. So after we generate our operational plans, right? There we go. The next step is for us to actually make the tool paths, which is the path that the machine needs to move through to achieve the cuts that it wants to do inside this machine. Now, another thing that's important for us to know is we don't necessarily need to do all of these cuts depending on what kind of accuracy we want. So these are the passes, and there's a rough milling, and then a contour milling, right? We might not need to have all those depending on the surface finish that we want to try and achieve. You also note here that this drill, center drill and drill offering has an exclamation mark on it. It's because I don't have that size drill bit in my crib. So it can't actually do that operation. And it's saying, hey, I came up with this operation that I should be doing for this process, but it didn't work, and so I couldn't. For the sake of speed, I don't want to actually run out all these operations. So what I'm going to do is I'm going to control click, and I'm just going to do, the first set of 3. So I got the dot, the L. Can we just do the Lura? L. Nope, that's the dot. I don't know, I can't figure out which ones are which. If I had labeled them, I probably could have got it better off. I'll just pick those 3. And then I'm going to generate the tool path for those 3. So I'm going to right click on that and then generate tool path. The only difference between doing this on the side here and doing it on the top, doing it at the top is going to do it for all of them, or any of the ones that don't currently have tool paths. And then right clicking it is only going to do it on the ones that you've selected. So I'm going to generate tool path for just those operations. You say, hey, previous is not regime. Do you want to continue? Yeah, I'll say continue. Why? Hopefully it doesn't do that for all of mine. I clicked on generate toolpath.
So I just clicked it at the top and it did that to me as well.
Yeah, I gave you the error.
Yeah.
These are the tools it's saying that I need that I don't have. Why didn't it generate a toolpath for other ones though? It should give us the toolpath for these ones. But it didn't. So this is our pocket. This is our, I'm going through these looking for errors. This is our features. These are our operational plans. And these are the actual paths that we would use. Why are we not getting any toolpaths? Did I miss something? Fixture coordinate system. I don't think I skipped anything. Yeah, it's just doing that for each of the contour mills. What's that? I tried to, just to see if that would help something. This is actually using the carbide. All right. Let me do. Record. This is extracting features. You can just actually work that guy with that. There you go. Takes a minute. Last thing we do after we have the doing the toolpath with code process. So I got that set up. Process that. So this is what it should look like here. When you do the generate toolpath, these will turn black. And then inside each of these, they'll have the actual toolpath. And then these are blue lines are the path it's actually going to take. And so once you have that, you create people on resources, run the simulation. That is a really bad toolpath. I probably would take out that operation. I was trying to get this to actually work. That guy, that path is really toolpath. And it's probably that second bumping operation that I just don't need. I'm not sure. Oh, it's like doing like a pecking operation. So I guess the point being that the operations that it automatically generates are not necessarily the best ones you can get. And you can go through and you can change some of these. So some of these did run. Okay, so we can look at some of these. So this roughing mill on the regular pocket, it was able to generate a toolpath on that one. This one was able to generate a toolpath on. I'm not sure why it's not doing the rest of them. We can simulate that and we can actually see what is running out. What I want to do is This is the difference between what it was actually able to cut and what I wanted it to cut with the current operations. And let's slow the speed down here. I'll go back to the beginning. And I want to show. I wanted to show you the material as it's live cutting it out. That's to the next Z level on my thing. Section view. This is display options. I know there's a way in here in the simulation for it to show the material as it's cut, not as desired. I'm trying to figure out which option that is on here real quick. What if I have it in the video? I should probably have it in the options here. Simulate, adjust tool paths if needed, feeds and speeds, and go back, post-process. That's the last part. I probably would take off that operation. I was trying to, yeah. I don't see the options different. I don't see a difference there. There is an option you can have here for it to show like what's actually being cut as opposed to the desired area. And it looks like all it's doing is a little bit of a facing operation and then doing a hole here at the bottom. It could be that I still didn't make these letters big enough. Yeah, it looks like my bit is just a little bit bigger than the size of my letter. And so it's doing like a facing operation on the front of these letters, and it's not actually going down into the parts to cut them. And at the end here, there it goes. It just doesn't show it the whole time. It actually does this cut into the A because that one was big enough, and I get that one. So really what I need to do is I need to make my bit smaller or my letters even fatter to be able to make that. We could also go to using a different shape bit and use like a V cut or something like that. But that's how you get that out. And then once you have the toolpath set up the way you wanted them to, then your last thing would be to post process. And then you can actually save this as a NC file, which is the file that the software that runs the engraver uses. And that would allow you to, and then cut the part, right? That's fine. Those are the ones that are going to cut. Yeah, anything that's in blue on here, like inside this, let me go back to our operational plan. Like all these ones in blue are not being performed, right? And also the ones in with the exclamation marks, those could be performed, right? Like they have a tool path, but I don't have the right bit for them. So the ones in black that don't have an exclamation mark are the ones that would actually get generated with this current plan, right? So wherever you guys are with this right now, you can save your part. You can save, do post-process to save an NC file. And then you're going to submit that to your week 8 progress submission. If you would like to, this is optional. If you would like to actually come in on Wednesday or Friday this week, and you want to see the second half of this and actually engrave something, probably take a little bit of time and modify that part file to get a path, a tool path that actually works for what we have. If you want a list of bits that we have available to us, I can get you that as well. And then send me an email to schedule something to come in to make that cut. And we can go in on the machine and you can see how the cutting process actually works. If you don't want to go through and do that process, then just watch this video at some point that goes over the process of loading the NC file onto the computer, sending it to the carbide, and then running the actual cut. Sorry, Marza, go ahead. So go to post process, click on that, and then you can just use this .nc, and then just pick a directory where you want to save it to and hit save. And again, that should be the same as it is in here. Post process, name the thing, hit save. All good? All right, just to reiterate, I am going to be here in class on Wednesday and Friday this week. Sorry, I'll be here in class on Wednesday this week. I won't be here on Friday this week. If you want to come in on Wednesday to make a physical thing or review or whatever, please feel free to do so. If not, that's okay too. I do suggest that if you're not going to conference, check out the Design to Manufacturing virtual conference. Maybe if you are going to conference and you feel like, doing a little bit extra things, maybe check that out as well. But this is what I'm kind of trying to use to levelize the amount of time you guys have for those who are or are not going to conference.